For the first time in decades, energy demand is surging across the country. Huge new factories and data centers are being built, the largest of which consume as much power as entire cities. You may have heard that a lack of available energy could slow down this growth and raise power prices for everyone. But here's the thing. The cheap, clean energy we need is already here. It's just in the wrong place at the wrong time. Take Texas, for instance. They have so much clean energy that a lot of the time they have too much power, and they have to start turning off power plants. In fact, last year, we wasted enough clean energy to power virtually all of America's AI data centers. So the question isn't how do we get enough energy, it's how do we get it at the right time. That's why my co-founders and I started Antora Energy, to convert fleeting intermittent sources of energy into a reliable foundation for our energy future. And to do that, we started with a blank slate. We looked at every type of advanced battery technology we could, from those based on lithium and sodium to molten salt and iron. And what we found surprised us. The cheapest, simplest way to store huge amounts of energy is to heat up a rock, namely solid carbon. Carbon is the element that powered the industrial age, fueling factories and furnaces, railroads and steel mills. But in our batteries, carbon isn't the fuel, it's the hardware. Here's how one of our carbon-based batteries works. When electricity is cheap, we run it through what's basically a giant industrial-scale toaster, heating carbon blocks up to over 1/3 the temperature of the surface of the sun. At those temperatures, the carbon blocks store more than 5 times as much energy as lithium-ion batteries, but at a fraction of the cost. In order to hold all of that energy in, we had to design our own insulation and seals, all made of carbon so that they wouldn't melt. And to get the energy back out again, well, that was actually easier than we thought it would be. The carbon inside is so hot it's glowing white like the sun, which means we can use light to transfer energy from the hot core to the outer edges, where we convert it into 24/7 heat and power for industrial customers and data centers. Our first factory is right down the road in San Jose, and we'd love for you to come visit us. It's one of the biggest battery factories in the country, with a production rate of 10 gigawatt hours per year, which is equivalent to about 1/4 of all of the batteries that were installed on the US grid last year. And as we speak, we are shipping these batteries to our first commercial project. It's a multi-gigawatt-hour battery installation that will soon be delivering affordable, reliable energy to a major industrial customer in the Midwest. That project, and the ones right behind it, point to what's possible. We powered the industrial revolutions of the past by burning carbon. But we can power today's advanced factories and data centers, the industrial revolution of this century, by building with it. Thank you.